Okay, so guys, in today's video, we will solve the code forces round 1054, which is division 3 contest. Okay, so this contest is held on like 25th, means like yesterday it was held. Okay, we will discuss the solutions of this contest. Okay, so what the A question is saying that we have -1, 0 and 1, okay, in our array. The array is given, size is given, and -1, 0 and 1 we can have in our array, and we can change any of the digit to its +1. Okay, so AI can be changed to AI plus 1. Okay, so it's like and we have to make this sum of the array, we have to make the product of that array, all array product of all the elements in that array strictly positive. So any element can be positive if minus minus will get cancelled and they get positive. Okay, so here minus minus will get cancelled and we will get the positive one for that, and for 0 we have to make we have to perform one operation, and the 0 will be converted into the 1. So the answer for that how much operation we have to perform will be 1 only. Okay, here we have to perform 4 operation, which like how that 0 0 0 0 will be every time they will be converted to the 1. So here 2 operations are there, and minus minus 2 minus are get cancelled out, and 1 minus is still left. So 1 minus cannot be cancelled out, so we have to convert it into 1. So we have to increment this to 2. Okay, by 2. So okay, we have to increment this by 2, this by 1, and this by 1. So the total we have to increment will be the 4. Okay, so here is the code. Okay, so we are taking the input array we are taking, and we are counting the A and B, means A is the -1 and the B is the 0. How much 0 we have to take. Now we have cancelled out all the by using modulo operation we have cancelled out that how many minus negative operations will be cancelled out, and we will get the remainder after that. Okay, so every two negative operation negative numbers will cancel out to them, and answer is equal to that B. Every time we have to add B because 0 will be every time changed to the 1, but if there can be 1 minus 1, minus 1 can be the frequency of minus 1 which is remaining can be 1 or 0 either. Okay, because all other will be cancelled out to them. Okay, so we can convert to the cost to convert it to the 1 will be the cost will be 2. Okay, because the difference between them is the 2. Okay, and 0 will be converted to the 1, and the cost will be also 1 here. Okay, that's why we are adding the B as only 1 for only 1, and the cost of 2 for A, that the number of occurrences of A into 2, because the cost to make the -1 to 1 will be 2. That's why we have added this to this into 2, and this into 1 we can say, like into 1 means it is the same thing. Okay, so let's discuss the B. Okay, if you have any query, so you can comment it down and I will try my best to answer your queries. Okay, this is the unconventional pairs problem. Okay, popular reality. Okay, okay. So maximum difference, we have to find out the unconventional pair such that the maximum difference among all the pairs is maximized. So here what we have to do, that we have to make the pairs. Okay, we have to make the pairs. We have given the array and we have to make the pairs. Okay, and we have to make the pairs like that that we will not be getting that. Okay, must divide the participants. Okay, so that minimum possible value of this maximum difference. So we have to calculate, we have to make the pairs. We can choose any of the two indices, and we can make the pair of them. Okay, and we have to find out the minimum value for it. Okay, minimum difference between them. Okay, minimum difference between them, between the elements in the pairs, and that minimum, we have to do the minimum of the maximum difference. Okay, so we have to find out the, we will make the pairs, we will form the pairs, and we will find out the maximum difference. Okay, and that maximum difference should be minimized. Okay, can you get it? So the maximum difference we have to find out, the pairs we are making. So the pairs we are making, we have to find out the maximum difference from that pairs. Okay, the difference between that pairs. Okay, elements of that pairs. Okay, and we have to minimize that difference. Okay, so what our approach saying that, so okay, so we have to simply sort that array. Okay, we have taken the array and we have sorted, and we have taken the that answer which is storing that maximum difference which we got. Okay, so we are making the adjacent pairs only. Why is like this? Because if we take like 2 we have, 5 we have, and 7 we have, and 10 we have. Okay, so we will make pair with the 10 with 2. Okay, just say just for an example, we are making the pair of 2 with 10 and 5 with 7. Okay, so the difference will be 8. Okay, and here the difference will be only 2. Okay, so here difference is minimum and here difference is the maximum, but we have to minimize the maximum difference. Okay, the maximum difference which we are getting from that all the pairs, we have to minimize it. Okay, to minimize this, we have to take the adjacent pairs. We have when we are taking this 7 and 10, we will get the 3, and when we are taking the 2 and 5, so we are getting the 3 again. So from maximum from 3 and 3, we are getting the 3 as answer. So our answer will be 3. Okay, so this how we will take the adjacent elements by which we will get the minimum from it, that minimum difference from it. Okay, okay, so let's do the C. Okay, C question. So in C, what is given that we have given the array. Again the array is given to us, and the max of that array should be equal to the k, which is k is also given here. Okay, k is also given. Here n is the given, and n is the size of the array, and k is given. That we have to make the max of that array equal to the k. Okay, so for this, okay, let's take the example from here. Okay, 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 so here the 7 and 4 is given. Okay, 7 and 4 is given, and this array is given that 7, this is the k, this is the k value, and this is the n value. Okay, so k is a 4, so max we have to make is the 4. Okay, so to make any of the array, its max is equal to 4. The 4 should not be present in that array, so we will count the occurrences of the 4. Okay, so frequency of 4 we can count. That frequency of 4 will be 2. Okay, after that we will count that all the numbers before 4, that is 0, let's say 0, 1, 2 and 3 should be present in the array. Okay, so 0, 1, 2 is not present here and 3 is present here. Okay, so 2 is not present here, so 2 we have to change the 2 with any of the other occurrences of the 4. Okay, so we can make this 4 as a 2 and this 4 as we can make as a 2 or any of the other number. Okay, we can make it as a 5 also. Okay, we can make it as a 6 also, but we will make it as a 2 or 2, whether it is a true 2 or we can make it as a 5. So its max will be, now its max will be 4. Okay, because so if you know, the max will be, the max is the that minimum number, that 0, 1, 2, 3. Now 4 is not present here, so 4 will be the max. And max can be, we can say the max is the minimum number which is not present in the array, from minimum natural number. Okay, so minimum natural number which is not present in that array. Okay, we can make it like that. Okay, again, so we have taken this frequency. We have to calculate the frequency of the k first and the frequency of the numbers which are before the k. Okay, so we have calculated the by using the map. Okay, we have taken the map and we have taken the array input and we have calculated the frequency of that every number. Okay, which is the every value of the array. Okay, now to delete, we have to delete the 4 occurrences of the all the k. Okay, all the occurrences of the k. Okay, so the map of k we have taken to delete. Okay, and to add means we have to that 0, 1, 2, 3, so that they should be present, okay, these numbers should be present in the array itself. Okay, so this number should be present here, so that's why we have taken that if mp of I is equal to 0, so to add means that 0 from 0 to k, less than k, that numbers, if that numbers are not present there, so we have to add one of the occurrence, minimum one of the occurrences of that number. Okay, so we have to add 0, 1, 2, 3, but 0, 1 and 3 are present, so we have added the 2 only. Okay, so now we are going to add, we can add the initially there is a 4 present. Okay, so this is our initial array. We can add on the place of 7 also and on the place of 5 also. Okay, but we have added it on the place of 4 because we have to replace the 4 with we have to delete the 4 and we have to add 2 also. So we can replace 4 with the 2. Okay, that's our approach, that we can replace the 4 with the 2 and that's how we will decrease our number of operations. Okay, so the number of operations will be decreased because by using the minus, that minus equal to the minimum of to delete and to add, means we can say the it is like the A intersection B. Okay, means like we have to do the A and B work at the same time. Okay, and in a one operation we are taking the one, we are doing the A operation and B operations also. Okay, means we are deleting it and we are adding it for the same position. Okay, and in the one operation only. Okay, so this how our operations will get minimized. Okay, so the minimum operations, so minimum from to delete to add. Okay, so to delete we will got from 8. Okay, now to add plus to delete, we can conclude it that that answer will be equal to that 2 add and 2 delete. This the remaining number of operations we have to do again. Okay, with the individually, like we have the individually A and individually B, so we can do that 2 add and 2 delete. Okay, means we have to add this one and delete this one. So if any of the operations are remaining, means like okay, so let's say the 4 is only 1 and we have to okay, we have 3 missing and this missing, that 0 1 2 and 3 are missing. Okay, so 0 1 we have should be present. Okay, 2 and 3 also should be present. Okay, these are missing, we can say. Okay, missing. Okay, and 4 occurrences of the 4 are 2. Okay, so 2 are missing and 2 are the frequency of the 4. So we will delete this, we will replace the 4 with 2. Again 4 will be replaced by the 3. Okay, and if again one of the 4 is present there, so the occurrence will be 3. So the 3 our answer means our 2 delete, like answer will be like the one who is means 2 add is minimum from the 2 add. Okay, minimum from 2 add and 2 delete. So this will be our approach, that if 4 the number of occurrences of the 4 are more, means like 4 is present there, so the 3 occurrences of there, and the answer will be minus equal to from it, because we are adding 3 and 2. Okay, so we are adding the 3, answer plus equal to this 2, both 2 we are adding. Okay, both 2 we are adding, and we are minus we are taking the minus of it, because we are replacing these elements with this, and that's our answer is taking here. Okay, we can do with like this also, minus this. Okay, this will also give us a correct answer. Okay, now let's go towards the D question number D. Okay, D is A and B. Okay, so in this question we have to make A B, we are given only A B sequence only. Okay, so every time we will give the string has present there the occurrences of A and the B, only A and B. Okay, string contains only A and B, and we have to make it like A are present on left side and A are present on right side only, and B, all the B's are in the same group, all the A's are in the same group. Okay, all the A's are in the same group, and B's are also in the same group. B's are also in the same group, and A are also in the same group. So we have to group B or A. Okay, in simple words, we have to group B and B or A. Okay, so we have to minimize the cost to make to group them. Okay, and for grouping this all the A or all the B, we can swap the adjacent elements only. Okay, so for this we can make like okay, we will take this. Okay, we will understand it by our code only. Okay, so let's say we have this. Okay, this is our example. Okay, so let's say we have taken the S string. We have we have to calculate the occurrences of A indices of the A. Okay, where it is present. Okay, so when we are that push back, means we are storing the indices of the A, we are storing the indices of the B again. Okay, so we have to merge them, not merge them, but we have to make it consecutive. Okay, consecutive A's we have to make, consecutive B's we have to make. So that's why for this we are storing their indices, and by using the indices we will find out that indices will have the middle, okay, median, okay, sorry, median, the indices will have the median. So we will find out the median. After that we will find out the cost to cost to swap the element up to the median, okay. So we have taken the input, and we are storing the indices of A, indices of the B, okay. Now cost of A and cost of B means it will find out all the cost of A together, cost of B together, okay, and we will minimize it, and answer we will find out, okay. So what the find cost, how the find cost function will run, okay. So first we will take the positions of any of the array, okay. If that array positions of the array, okay. So we have to merge means say we can say we have to make them consecutive, okay. So to make it consecutive we will take the position vector, position difference, okay. The position difference will now say like this position difference will tell us that position difference should be like 1 1, okay. So 1 1 position difference should be there, means like if that position array is like 4 5 and 7, okay. So the position difference between them will be like position I minus of I, means like position of I is the 4 minus of I is the 0, okay. Now 5 minus of 1, okay, sorry, this will be the 4, okay, 4 because position of I will be the 4 minus of I means the 0, okay. Here now position of I will be incremented by 1 and position of I will be 5, so 5 minus of 1 will be 4, okay. So the difference we can see that when the difference is of 1, okay, here 1 difference is there, here 2 difference is there. So now the increment I will be incremented and 2 we will have, so the 7 minus of 2 will be 5, okay. So we have to swap it, okay. The 7 position, the A which is present on the character which is present on the 7th position, we have to swap it to the 6th position, okay, to the 6th position, and then we will get the that 4 4 4 difference, okay. The difference will be equal, okay. So now by using this we have to calculate that how many operations we will take to make them consecutive, okay, to make them continuous, okay, like 4 5 and 6, this will be continuous manner, okay. So we have to group them. So for grouping all the A or all the B we have to make them continuous, okay. So grouping, we can say grouping means making them continuous, okay. So making them continuous, okay, continuous, okay. Okay, so now the cost which we will be required to make them continuous, just like when it was 7, so the cost required to make it continuous will be the 1, okay. What will the cost? Median is like this will be the median, okay, median, okay. This is the median of this, and this median will be calculated, and the cost to travel, cost from 5 to median will be calculated, okay. 5 to median will be calculated, okay. So 5 minus of 4 will be 1. There is a 1 cost, 1 will be the cost to make it continuous, or group all of them into single A A group or single B group. Okay, this will be the cost. Okay, cost will be the position difference, means position difference we have calculated. Okay, we have name as a position difference, but it is not a position difference. It can be contained like indexes, like we have to make it continuous. So we have displayed, we have find the position difference, we can say like that. Okay, position differences, and by using them we can calculate the difference between median and the position difference of that means current index. Okay, so we can contain the cost. Okay, we can calculate the cost plus equal to the absolute, means like the difference between the, okay, it can be like 3 also. 3 means like it is present in the 3. Okay, this can be the 3 and this can be the 4. So this position difference will be it can be the minus, but difference cannot be the negative, so that's why we have taken the absolute. Okay, and the n by 2, you know, the to calculate the median, that median is present in the middle of that any of the array. Okay, we can make median as any of the index, whether it is odd or even, we can make it as a n by 2 only as a median. Okay, and this will calculate our cost to group the A or group B. Okay, and we will return this cost, and this cost will be stored in the cost A and cost B, and we will find out the minimum cost from that A by using that to make the group of A, to make the group of B, we have individual cost, and we will return the minimum from that cost, and that's our D solution. Okay, so let's see the question number E. Okay, so what it says that, okay, so it is a hidden knowledge of the ancients. Okay, so here we have given in the input. Okay, we have given input like N, K, L and R, and after that the size of array we have given of size n. Okay, so n, k, l and r. So what n indicates the size of the array A which has given to us. Then k what indicates that we have to find out the such a sequence of length n. Okay, so we have to find out that how many number of sequences we can obtain, okay, from it. Okay, how many number of sequences. Okay, we have to single integer separate line, the number of contiguous subarrays that meet the specified condition. We have to find out the subarrays, how many subarrays we can make from this conditions. Okay, by satisfying this condition. Okay, so to get this, that k indicates that we have to find out these subarrays which are having the k distinct integers. Okay, and that subarrays should have their length, minimum length will be L and maximum length should be the R. Okay, the subarrays length. Okay, we are talking about the subarrays length of that subarrays should be maximum R and minimum should be the L. Okay, so the length should be between L and R. Okay, and also the k distinct integers should be present in that subarray. Okay, so we have to use map here to find out the distinct integers. And also, okay, what were the approach that I guess you have understood that the problem statement. Okay, so once try to solve it by yourself, and after that if you are not getting this solution, so you can watch that hints and get to know about the hints by using taking the help from the solution. Okay, so we have taken the input here, the array, the left margin, right margin, which should be which is given to us. Okay, and k, and left margin and right margin. Okay, after this we have given the left and okay, we have taken the answer is equal to 0, that how many subarrays we can make. Okay, After that, we the constraints are quite yes, constraints are like 10 to the power 5 u, and this is n, which is like the 10 to the power 5 all. Okay, so that's why we have to solve it in the optimized way, okay, only. So we have used the map here, map. So what the map will do, that the left map will just explain with the example. I will explain with the example to you. Okay, just let's say this is our example. Okay, so here 1 2 3 1 2 3 is given. Okay, 1 2 3 is given, again 4 5 and anything can be given here. Okay, so okay, sorry, let's take that only example which is given to us, and let's take this also example. Okay, this examples also. Okay, okay, so in this example, in the first example, what we can do, that we can take the left and right one pointers. Okay, two pointer approach we can apply here. Okay, so our index start from 1 to n only, and our two pointers left and right will make sure that the left, okay, the minimum left will apply that the, okay, so the left will be stop where, okay, stop where the distinct elements will equal to k. Okay, so L will be this. Okay, again the R will be also this, but R will be the maximum limit and L will be the minimum limit. Okay, so this is the minimum limit and this is the maximum limit. Okay, so let's say that this is the 1 2 3. Okay, k is this. Okay, this is the k is equal to 3. Okay, k is equal to 3 we have given to you, here it is given. Now 1 2 3, in our set there are now set is containing 3 elements. Okay, 3 distinct elements. Again, so the left will be here. Okay, left will be at this position now, and the right will be again going on to the right of the left. Okay, because right will not stop here only, because again the 1 2 3, if he adds 2, he adds 3, so it will not be able to that. Okay, sorry, I have done a mistake here. L will be here, because here we have satisfied that set value, that k value, the distinct integers should be 3. So minimum distinct integers should be 3. So here we have satisfied the condition by adding 1 2 and 3 in the set. Okay, set or map we can say. Okay, map is also having the count of the distinct elements. Okay, now again the right will go here, the map size will be remain same. Okay, only the count of the 1 will remain will be 2, count of 2 will be 2, count of 3 will be 2. So now the end of the array he has arrived. So the left will be plus plus, while it will be while it will not it has not reached up to the end of the array, and after that right will also be moving forward while he has not reached up to the end of the array. So this two loops will be going on in the right direction. Okay, so again the R will be here. Okay, so this is the left and right boundaries. Okay, so now we can have the sub array this, okay, which having the length 3, again we have the sub array is this, which having the length 4. Okay, sub arrays we will be having sub arrays we will be having of length 3, we have 4, we have 5, and we have 6 also, because this 1 2 3 4 5 and 6 up to this, up to the R boundary this. Okay, if there is something another has present, that 5 is present here, so we will not add the R to here. Okay, the R will not go up to the 5, because when we add the 5 to the set or the map, so the map size will be increased, map size will be 4, so it will not satisfy this condition. So that's why we haven't added the 4 added the 5 to the map. Okay, now okay, here the condition has given that and map dot write, okay, mp write dot size is less than equal to the k, means up to which it will increasing, up to which it is not getting up to which it is less than or equal to the k size of the array. Okay, and if it has reached to the greater than that, we have matched the condition here, so map dot write mp write dot size is greater than the k, so it will be decreased, because decreased by 1 only, because when we are when this size is greater than k, so our loop will be break. Okay, so that's why it has only be running after satisfying the condition, it will be run for only one iteration only. Okay, so we will be decreasing for only one. Okay, now sub arrays we are getting from this are or of size 3 4 5 and 6. Okay, but the size range we have is the 1 to 6. Okay, this is our range of the size which we want. Okay, so the minimum should be the 1 and maximum should be the 6. Okay, so all the size sub arrays, okay, all the sub arrays of this size will be included here. Okay, and if this could be the 4, okay, if this will be the 4 and if let's say this will be the 5. Okay, so this is the 4 and this is the 5. Now 3 will be excluded and 6 will also be excluded. Okay, because this we have the inclusive range. Okay, so the 6 will also be excluded and 3 is also excluded. Okay, so how we will exclude this ranges? Okay, so for exclusion of this ranges, we will be finding out the max from for the left range, and for the right range we are calculating the ranges which we are including only. Okay, so the max from I plus left margin minus of 1, we are taking this. Okay, I plus left margin of 1 minus of 1. Okay, so what it will do doing that I index, it will be starting from this ith index. After that, after first index, we are now starting from the 1 2 3, but after arriving on the second index, it will be starting from 2 3 and 1. Okay, this will be satisfying, and the left will be at this, okay, this position. But okay, now we are doing for the first index from this 0th index. Okay, so it will be calculated like left, that I plus left margin minus of 1, and the left, that maximum from it, like it is arriving at this position 3. Okay, it will be arriving at this position, and it will be arriving at this position. Okay, left. Okay, left is 4. Okay, so the length which having the more, okay, which is the more from this 2, so we are getting to that one. Okay, after that right is there again. Now right is also here. Okay, so the I plus of right margin minus of 1 we are taking, after that right the minimum from this and this. Okay, we are taking minimum from that and that. Okay, now now we have this okay, we have calculated the maximum margin. Okay, so the maximum margin that L and R having what L and R are having that yes, this is the L and R. So L and R, this L and R are contributing to the that what is the length, what is the minimum length and the what is the maximum length. Okay, we can say like that. Okay, so now the left we are calculating by using this, and the right we also are calculating by using this. Okay, so the final answer which we are including, the final subarrays, final number of subarrays which we are including will be this. We are storing it in the temp, and after that right minus of left plus 1. Okay, these are the number of subarrays which we are storing. Okay, which are the valid subarrays. Okay, which are which having the k distinct elements, also which are into the range of the left and right. Okay, so we have added to the answer here. And why we are taking the 0 LL, because there can be some conditions that the left, okay, that the left will be at this. Okay, left will be at here, and left will be at here, and okay, sorry, left will be left can be at here, and right can be here. Okay, so right is here and left is here, and if the left minimum and right minimum are not satisfying any condition, like, okay, so it can be able to come as a negative. So that's why we have added here that maximum from temp, maximum from 0 and temp. So if negative value has come, so we will add nothing. Okay, so that's how our answer work, and this is our approach. So if you have any doubts, so you can comment down, and for more such video, please subscribe to our channel and support us to help to make such more such videos, and we will be sharing the next code forces round solutions soon. Okay, thank you.